Now here's a graph of a material being stretched. Now it could be a spring or it could be a metal wire. And what we've got to do is match the descriptions to each part of the graph. Notice that we've got force on our y-axis and extension on the x-axis. Sometimes these guys get swapped around, so be alert when you're looking at stretching graphs, which axis is on which. Now, first of all, let's start with Hooke's law. Now, Hooke's law is where extension is proportional to the force applied. So that means if you double the force on the spring, you will double the extension. And when something is proportional, it will go through the origin on the graph and it will be a straight line. So this is Hooke's law. This section here is Hooke's law. Now we get up to a certain point when the graph starts to curve and it's no longer proportional. It's no longer a straight line. And that is called the limit of proportionality. The limit of proportionality, so that's A. After that point, Hooke's law will not work. And there's often a little bit more stretching to be done before we reach another point called the elastic limit, which is here, C. And the elastic limit is when the bonds of the material actually start breaking, and we start a type of deformation called plastic deformation. And after this time, after this point, the material will actually be permanently deformed. And if we were to release the force, the stretching force, it might return along this line, and we'd see that there would be a permanent deformation when you got to zero force, and there it is, a permanent deformation. Okay, so that's a good graph to have at your fingertips. And remember that Hooke's law is the straight part of the graph where it goes through the origin and then up to the limit of proportionality, after which Hooke's law will not work.